everyone. My name is Jenny, and I am the CMO of Project Glimmer, and we are so excited to see everyone here. I love the chat. Everyone's answering questions and feeling the love. We're super, super excited to have you all here today. Our Empower Hour is the first of a series, and we are going to talk about one of my favorite topics. We're going to talk about beauty and personal care products. But this time we're taking a different spin. So we're going to start at the beginning and really learn about the chemistry behind all of these products because we all love the finished goods, how they work, but let's talk about how and why they work. So we have an amazing team here from Dow and also from L'Oreal, and we're going to hear from our panelists about how they work together to create the products that you know and love. One quick housekeeping thing. We want to make sure that everyone's questions are answered. So make sure you are asking questions in the chat. We're all going to be monitoring them. You have an amazing lineup of panelists who are going to take you through their roles and answer your questions. So without further ado, I'm going to hand it over to Tiffany, who is going to lead you through this session. So Tiffany, over to you.
Thank you so much, Jenny. I am so happy to be here, everyone. How's everybody doing out there today?
Good.
So, did I hear it good? Awesome. So, my name is Tiffany Torrain. I am the Inclusion Relationship Manager at Dow. I'm in our Office of Inclusion, and I basically describe my job as taking Dow's values of inclusion and belonging into our community. I work and live in our headquarter community in Midland, Michigan, and that's where our employees bring their families and they come to make a new life. So we want to make sure that when our employees and their kids and their spouses and partners are here, that they feel as though they belong. So I work with a lot of community partners, and I tell everybody that I get to do this great job. So on this slide here, you'll see just a little bit about me. Involve is one of our partners, and I attended their award ceremony where a few of our colleagues were honored, and basically we took on New York, if you will, and did some amazing things, just recognizing the inclusive work that we do. And right in the middle, I love this picture of my family. I have a son who's 17. His name is James. My daughter is 22. She just graduated from college. She attended Spelman College in Atlanta, Georgia. And in the middle are some of the things that we spend our time doing. So my son plays football. My daughter ran track. Now, of course, she's in college. So all the activities, all the things, that is our lives. I'm an attorney by training. I attended Southern University Law Center, and so that's the bottom of the slide. And I'm also a life member of Alpha Kappa Alpha Sorority Incorporated. And I have both those slides just as symbols that, one, I value education, knowledge, sharing of information on the law side. And for the sorority, it's community service. So everything that I do, even the work that I do at Dow, is built on service. So I will stop there, and I am going to turn it over to my colleagues at Dow as we begin our conversation about the chemistry behind the products. First, we're going to jump to this video, and then we'll start our conversation. So if you have questions for me, just drop them in the chat.
Welcome to our personal care application R&D lab. Today we're going to discuss a hot topic. Although I'm a personal care cosmetic scientist, I'm also an avid consumer who shares the same concerns about her hair. And consumers don't want to choose between great looking style and healthy hair. Exposure to heat from styling tools such as hair straighteners, curling irons, and blow dryers can cause severe damage to the hair, making it feel brittle and dry, leading to split ends and breakage. From concept to creation, our experts can offer options to support your formulation development and application claim substantiation. We have been extensively testing our ingredients for years to fully understand how they protect hair from heat damage. Materials and test methods are ever evolving, and Dow is leading the way, developing new test methods, being at the front line with a customer and consumer centric approach.
Awesome. Thank you, Paige. So now I'm going to turn it over to Stephanie, and she will introduce herself and tell us a little bit about what she does as an R&D leader at Dow. Stephanie?
Awesome. Hi, everyone. So excited to be here today. So I'm Stephanie Polisari. I'm a senior R&D leader here at Dow in the process research space. I've been with the company for about 16 years and am located in Midland, Michigan.
Michelle, would you like to introduce yourself?
Sure. Hi, everyone. I'm Michelle Cummings. I am a senior research manager here at Dow. I also live in Midland, Michigan, where Tiffany and Stephanie live. And I've been with Dow a total of 28 years.
And Nicole?
Thank you, Michelle. And now Nicole. I'm sorry. I was on mute.
Hi, everyone. Nicole Collins. I work in raw material sourcing for L'Oreal. I've worked at L'Oreal for 7 years. I've been in this position for almost 3 years. Super excited to be here and share more about my journey and how I became in this position.
Awesome. Thank you. Sounds like a lot of science that we're going to dive a little bit more into. And I need everybody to repeat after me in the chat. Science is amazing. Just a little homework. So let's jump into some questions about some specific questions about our career journeys. And Stephanie, I will start with you since I'm seeing your slide, and then we'll just go around. So tell us a little bit more about your role and just your day-to-day. Like, what do you do?
Yeah, so as a senior R&D leader here in process research, I lead a team of engineers and technicians, and we are really tasked with scaling up new products and delivering new process technology solutions. So really what that means is taking things from small lab scale and trying to predict and plan for, and then ultimately get those to full-scale operations so that we can create products and ingredients that go downstream to consumer goods.
So let's back up because I'm looking at your slide here and it says University of Michigan. So how did you get from University of Michigan to a senior leader in R&D? Just what sparked your interest in science or chemistry?
Yeah, so events like this are really what piqued my interest in engineering. So I started going to STEM for Girls events around like 6th grade. And that's where I first heard about chemical engineering. And it really propelled me to kind of lean into chemistry and math courses in high school. And I really took an interest in kind of how chemistry played a role in my everyday life. And an obvious place is obviously like beauty care, cosmetics products, especially at that point in my life. But I frankly had a bit of a windy road before I got to apply my chemical engineering skills to beauty care products. So I studied chemical engineering at the University of Michigan. And during my time, I spent a couple of years in a material science research lab, and I also got to do 2 consecutive internships at General Dynamics Land Systems, where I worked on armored vehicles. So you can see one here. So I worked on hazardous material elimination, looking for new types of coatings that could withstand things like desert and sand conditions. Following graduation, I joined Hemlock Semiconductor, and there I worked in a role in process engineering as well on new reactor technology. And it was a really good mix of theoretical application, really applying it to high purity silicon that's used in computer chip manufacturing. all of that really was meaning like breaking, cleaning, and making silicone rock. Okay, so very different from the beauty care space. But I eventually made my way back here and was able to apply, my chemical engineering, problem solving skills, and really got to come back to the beauty care space and use those in this fast-paced, customer-driven atmosphere.
So, and I'll move to Michelle next just to give her a heads up. But just tell me, was there something when you were a young girl like that sparked that interest in the chemical industry and cosmetics specifically?
So really, again, seeing different speakers and women in chemical engineering. Those are my first exposures to kind of science related careers. Very different from what my family did. And so just kind of seeing them work through, problem solving was one of the key things that I really enjoyed at that time and kind of saw. And obviously, I think the coolest thing about what we do is you work on something and you get to see it on the shelf and use it yourself. That's like the best part, right? So that is really rewarding to me.
Love it. So thank you so much, Stephanie. Michelle, we're going to move over to you. So same question. So tell us just a little bit more about your role at Dow and how'd you get here?
Perfect. Yeah. Um, so in my role at Dow today, I lead a group of synthetic chemists, and we develop brand new materials that are used in a variety of consumer and industrial products, which also include developing materials for personal care. And my team partners really closely with Stephanie's team, so we make the stuff in the lab at the small scale. And then we work with Stephanie's team to be able to take that small scale to a much larger production scale. And so within that space, that personal care space, we do work with silicone chemistry as well as organic chemistry.
So just a quick question because I mentioned I went to law school. So what's the difference for me and for anyone else who's wondering in silicone chemistry and the other chemistry?
Yeah, so silicone chemistry really means that we're working with the silicon molecule. And typically, how that is used is to either deliver a very low surface energy, so like water will not spread across a surface very easily, so like waterproofing and that kind of thing. Um, that is a key feature of that. And then it's also very flexible. And so when we think about like very traditional silicones, we are looking at stuff that you would buy off the shelf that's a full silicone product is maybe like a bathroom caulk or something like that. But we're breaking that down into like small polymers. And then
Mm.
those polymers are flexible polymers and they work to protect moisture and create a very nice seal or barrier, for example, like on your skin, so that that moisture is contained within your skin and isn't easily evaporated and released. That versus organic chemistry, we can also achieve a lot of those similar benefits from an organic chemistry standpoint, but those are using the carbon atom more, and depending on the carbon atom, more than on the silicon atom.
And I saw some very bright, aspiring or current chemists in the chat
I
who
see
knew
that
these things.
organic carbon
So,
products. Yes.
yes,
Organic
yes,
chem. Yes.
I love it.
Absolutely.
I love it. You ladies are amazing. So, did you always know you do this? Like, what
So
led you down this path?
I did not. So I actually, out of high school, I was determined that I would go and become a physician's assistant. And so I started going into my college journey with that in mind. So I was, of course, taking my general ed classes and that kind of thing. And in that time frame, because I live in Midland, Michigan, Dow is one of the central large uh, employers in Midland. And I had an opportunity to do a co-op, so go to school and then work at Dow while I was going to school. And so I ended up in a plastics testing lab where we were testing the material properties of various plastics, and like the formulation would change. So the ingredients to make that plastic would change, and we would test it for those material properties. And in that experience, it like clicked for me. And I was like, oh, I totally get this. I understand it. It's very clear. And so that changed my direction. So I changed my major at school and I went into chemistry instead of specifically focusing on prerequisites to go into the physician's assistant program. And so that really like started my journey down this path. From there, going to school, I actually was able to get a full-time role and get hired in. And at that time, it was with one of Dow's joint ventures called Dow Corning at the time. And so I hired in, and I was then working full time and going to school and finishing out my degree. Once I finished out my degree, I transitioned into a new role in Dow Corning, and I worked on really contributing as a researcher to a variety of different products. I happen to be aligned to the where we contribute to the electronics industry, so making materials such as a clear silicone, optical silicone material that goes into like car headlights and LEDs and that type of thing. So it's a silicone elastomer material. It's very flexible and rubbery and very clear. And so I spent quite a bit of time in that space and our electronic space, and then transitioned into a manager role where where I'm now like leading a group of synthetic chemists where we're making these brand new molecules.
So it sounds like a bit of a winding road, and
It
I heard
is.
you talk a little bit about a pivot. So, and I'll just chime in before we move to Nicole that it's okay to make a pivot. So, to all of our future scientists, whatever path you take to get to where you think you want to be, and like Michelle said, it just felt right, right? Keep going. It's okay. So, Nicole, we will turn to you now. I don't see you on my screen. Are you there?
I'm here.
Awesome. So, yeah, tell us what you do and how did you get to L'Oreal?
So currently I work for L'Oreal in sourcing. I'm a raw material buyer, so I basically make sure that all the ingredients that are in your beauty care products make it from suppliers like Dow to our factories. So basically, let's say you're making a recipe at your house and you go grocery shopping for uh, butter. There's a lot of options, a lot of different kinds of butter. There's salted, unsalted, margarine, liquid butter, etc. And you weigh the options. Maybe it's based on cost, what's the healthiest, or what's the most well-known brand, what's going to work best in your recipe. That's exactly what we do. We buy ingredients that are safe, that are compliant, that are made by suppliers that we know and trust and align with our principles. And of course, we want a good cost as well to pass on a good cost to the consumers. But essentially, it's as simple as that.
And what sparked that interest? Is this something like, did you like to cook? You mentioned recipes, like putting things together.
So I took a little bit of a pivot as well. So I my background is in cosmetic chemistry. So I started at Avon and I worked in a pilot lab for 12 years, and then I worked in a formulation lab for 3 years. And then when I first came to L'Oreal 7 years ago, I worked primarily in packaging. I worked in Ralph Lauren product development. And I was working more in product development, and I loved it. And I had like a great 4 years there, but again, it was a pivot, and I wanted to come to sourcing, to back to my roots, and work with raw materials, but on the business side.
Mm.
Um, so really enjoying what I'm doing now.
So you mentioned a good point. So you knew where you wanted to be and you used a skill set that you picked up. So even though we take pivots and turns, it doesn't mean that what we're doing won't be helpful down the line, right? I like to tell my kids everything leads to something else. So just put it in your back pocket. You never know when you'll need it.
Exactly. And
And go ahead, you go.
oh no, I was just going to say, an engineering degree is really just a very versatile degree, because you can, it allows you to pivot to a lot of different things. You can be you can work in chemistry, you can work in packaging, you could work in business. It really allows you to do it allows you to pivot in that way.
Awesome. So it looks like I have just another minute or so, and I'll start with you, Nicole, and then we'll move to a round robin. So, Nicole, what surprised you most when you entered the beauty industry?
I would say, well, at least this was true for me when I worked at Avon and also at L'Oreal, but the fast pace surprised me so much, because I had done prior internships in the pharmaceutical industry and also at food and beverage at Pepsi, and the pace at which they launched was very slow. And in pharma, it was like, I don't know, one launch a year, if that, and in Pepsi it was, a few. And in beauty, it's hundreds of launches a year. It's so fast paced. It's incredible. You really have to keep up with trends. It's super fast. It really shocked me.
Yeah, and preparing for this, I did some research, and of course, I wear makeup. And you want, as L'Oreal and other companies, you want to give people what they want. So that
Yes.
would make sense, right?
Yep. And
So
that's
a
why
good
I've stayed.
question. Yeah, I mean, and it's ever changing, so you're never going to be bored or, yeah, unmarketable.
Exactly. Hmm.
And so, question for you, Nicole, before, and we'll move to Stephanie. And this was a question in the chat. What is your advice to young people or young students who want to do what you do, who want to get involved?
In sourcing specifically, or just um,
Let's start with sourcing, and then we can, and then if you have like the industry in general.
sure. So, like I said, I think, um, and this, and this is the advice I give to my kids too. Like, I think an engineering degree is a very versatile degree, because it allows you to really pivot into a multitude of different fields. Like I said, you could work in the labs. You could be an actual engineer. You could work in the lab. You could work in packaging. You could work in business. It really allows you that versatility. But sometimes the reverse can't be true, right? If you major in, I don't know, education, you really can't be an engineer. So you kind of have to start from the most rigorous degree, and then you could pivot from there. You can be a teacher, if you have an engineering degree. So for me, it's really start with a degree that can give you that versatility.
Awesome. And Stephanie, over to you, and thank you, Nicole. So, any surprises? Anything that you learned or expected to see and didn't see? Like, tell us about it.
Yeah, I think one of the biggest surprises for me was right the number of ingredients sometimes that we see in beauty care and how they all have to really like work together to do the job that we're wanting them to do. So that complexity wasn't something I really thought about a lot until you get into this space where you're doing those compatibility tests and making sure that the material you're making is meeting the mark every single time you make it.
That's good. Good. And same for you, Michelle.
Yeah, I think I would say similar to Stephanie, right? The complexity that goes into the products. I mean, you go to the store, right? And you go to get something off the shelf and you flip it over and you look at all of the ingredients in there. And I think it is like important um to see like how much goes in there to actually deliver the performance that you're looking for in that product. And I think what also is super exciting is for me from a chemistry standpoint is being able to look at those ingredients and be like, oh yeah, I know what that is, I know what that is, right? I can kind of go through that ingredient list and understand what's going into those products, and then like, why is this actually working? Why do I really like this brand over another brand, right? And so looking at that, I think is I don't know, it's exciting to see.
So you guys in the labs sound a lot like me as a consumer. I have to buy the products and I have to figure out, oh, well, this worked with my skin. This didn't work with my skin. I like this product. It's ashy on me, like, the whole thing. So, and I like that, and I'll just drop a plug for L'Oreal, how they have like an agnostic system where I can go on digitally and figure out, oh, this is a match for you or this isn't a match for you. So I'm sure you guys at L'Oreal can put that in the chat. So I got a question from the chat, and it reads, how do you recommend students get acknowledged in competitive fields like chemistry and STEM, and what is the best factor that will help their journey? So, like maybe grades, internships, and several of you mentioned that you did just that. So, anybody want to take that?
Yeah, I'll take a stab at it and then have others like chime in. But so yeah, I think one, having a co-op or internship experience while you're going to school is super helpful. One, it allows you to have that experience out into industry, or even doing like a research, like an REU type experience, right? If you want to go into academia. So, taking advantage of that, I think you learn a lot about yourself. You also learn a lot about what you like and what you don't like. And that can absolutely guide your journey from there and put you into a place where you're most set up for success. And so I would highly, highly encourage that.
I love that. Stephanie, Nicole?
Yeah, I will just echo that. And I think, the early time is the time to try different things. So try the lab, try, right, the manufacturing experience, get a feel for what you like and what is invigorating for you, because it's going to look different for everybody. And that can help you kind of direct what type of work do I want to be doing day to day.
Fully agree. Yeah.
Yeah, and I just say, and I mentioned at the top that I do a lot of work in our community. So I work with our schools. And if I have a school or a group who wants to come in and see what we do, we have those types of visits that we arrange. So if there's something in your community where if you're not seeing it, reach out to organizations like Dow, like L'Oreal, to see if they do visits or even a job shadow, because sometimes just seeing it makes sense. But definitely those internships. And I'll just chime in, Michelle, you, I believe, had ACS on your slide. Can you just
Yeah.
give us a brief overview of what ACS
Yeah.
is? And because I know they do work with students.
Absolutely. So ACS is the American Chemical Society. It's one of the largest professional societies for like the US, and then we're also ACS has recently gone global. So we have a lot of international chapters also. So within ACS, it being in a professional society, I would say in general, right? There's a lot of benefit to that. I put some of this in the chat already to answer some questions, but networking is huge. You also get to see a variety of technologies that you normally wouldn't be exposed to. You get to talk to those people that are working on those technologies. And so, again, like as you decide a career path, especially as a student, if you have an opportunity to go to a professional society gathering, I think it's really helpful so that you can get connected with other like professionals that are either out in academia or in industry, and you can ask those questions, and they're excited to be there and talk about it because most like all of these professional societies, they're volunteers, right? They're doing it because they love it. They're doing it because they want to talk to people about it. And so it is a great opportunity for students to come in and learn. Also, just a note too for ACS and other professional societies, a lot of times they have grants and awards to have students come and present their work if you have research work that you've been working on. And so again, that gets you exposure to other professionals in your field, and kind of starts to get your name out there. And so it might lead to co-ops or internships, and it might lead to further conversations about what your career path want or what you want your career path to look like in the future, and those networks to reach out to folks when you're ready to go land that full-time job.
Awesome. So, at Dow, we have what we call employee resource groups, and we have 10 of them, and many of us are involved in different ones. I saw some on some of the slides, and I'm a member of our women's inclusion resource group, and I saw this documentary that says, and I, y'all help me if you remember the topic. It was the title. It was like science like a girl or something like that. But typically, and this was before now, 2026, when you hear the word scientist, who did you think about? It wasn't us. It wasn't you ladies who are rocking it in this industry, right? And that documentary, and I'll drop the title in the chat, was like so amazing to those of us who are not there, but it's what you do every day. So would you say now that you're in this field that it's still dominated by men, have women, kind of taken their place at the table? I'll start with you, Nicole. What are your thoughts?
At L'Oreal, am I okay? At
Yeah.
L'Oreal, I don't see it honestly. I know it's not the norm. Maybe in other companies, but at L'Oreal, we don't see this disparity between men and women. We have a lot of women working, and um, we don't see it. But I know it exists at other companies for sure. But at L'Oreal, we don't have it.
So, and has it always been? Has it changed over the life of your career?
For
Even
sure,
though,
for sure. When I
yeah.
in college, and this is a long time ago, but I was the only woman in my class, in my chemical engineering class. So it was all men. I had all men professors, and then in the three other jobs, it was for sure male dominated. Um, so when I got to L'Oreal, it was definitely a culture shock. I couldn't believe it for sure,
I love it. But in a good way.
in a great way, in the best way. Yeah.
Stephanie, Michelle, any of you?
Yeah, I would say, I think it certainly has changed. And I think it's different in each company. So I started out at Hemlock, which was a much smaller company, much more male dominated. But I was still able to find my people. So that's just something I think you can find your people, you can network, find your mentors that can help you through tough times and raise you up right when it's time to celebrate. So I think here at Dow, certainly there's a lot of diversity, and we definitely want to celebrate that and help each other.
And that documentary was called Picture a Scientist. And some of my Dow colleagues, I see you nodding. Michelle, what about you?
Yeah, I think so. I think I stated before, right? I've been here for 28 years. So I've definitely seen a progression over that time. There are much more women now, even in our like pipeline of new hires, which is super exciting to see. And so that is something that here at Dow we have very much embraced and taken a lot of time, right, through our employee resource groups and other resources to make sure that we are creating a space that is very inclusive, and it is a space that, you know, women can come and thrive and have a very long, fulfilling career and have, you know, a tribe too, that is here to support you.
Okay, and I need someone to keep me honest on time, but I have just a round robin that I mentioned a while back. We've just been having a great conversation, so I think I'm taking us a little bit off script, but I have a question for you about what's actually inside of our beauty products, panelists. So when consumers look at the ingredients list, what do they most often misunderstand? I'll start with you, Nicole.
Um, I think in an ingredient list, anything above, and maybe folks don't know this, but anything that's above 1% in concentration in a formula has to be listed in descending order on the ingredient listing. And then if it's below 1% in concentration, it could be in any order. So I think some people assume that if an ingredient is like far down in the list, it's not like added at like a high performing level, like maybe it's just sprinkled in as pixie dust. But in reality, some active ingredients don't need to be at a high dosage. I use a retinol product that has like 0.05% retinol. It's hardly any, but it's extremely active. I think that's probably a misconception about ingredient listing.
I learned something new today. I was 2 years old when I learned that, so thank
So
you.
water is usually the first ingredient listed. That's
It's
why.
always water. It's always water. I love it. So, Michelle, question for you. What are some of the most important ingredients in products like shampoo, skincare, or makeup, and what do they actually do?
Yeah. So if you think about uh, shampoo or like your skincare routine, it's a lot about cleansing, right? And so we typically primary ingredient in there that is the active thing is a surfactant. And that surfactant essentially allows like the oils and dirt that you're trying to cleanse off to be carried away in the water that you're rinsing it with, or if you're using like a pad, like a makeup wipe or something like that, right? There's water in that makeup wipe, so that surfactant allows that makeup to transfer from your face onto that makeup wipe. So that is one key ingredient that I think really drives the performance that you're looking for as a consumer. A couple of other things, just in makeup and or lotions, conditioners, that kind of thing. Definitely like hydrators, so humectants. are a really key ingredient there. And so you typically are looking for some type of delivery of moisture and then some way to retain that moisture. And then I think the third one that I just want to point out are emollients. And so really softeners. So softeners to your skin. People are looking for hydration, soft skin, that really nice feel. Throughout the day and that it retains throughout the day. And so those are some key things and what they do.
Awesome. So I think someone on the team can help with these vocabulary words. Michelle just just gave us her
Yeah,
homework. Can you drop the spelling in the chat because someone is asking?
absolutely.
Thank you. And so, Stephanie, over to you. What's one ingredient or technology that teens use every day, but probably know nothing about?
Well, I have to go to silicones because it is everywhere. So you definitely use it every day in lots of different contexts. But a couple examples maybe. So your conditioner, right? Silicones are one of the things that help make it easy to comb and brush through when you're getting out of the shower the next day. Your primer, right? So this is what's like providing this nice smooth surface for you to apply your makeup on. Hair serum. So hopefully I don't have too many, but helps control the frizz that happens with humidity. And then lipstick mascara has it in there, and that's really what's helping keep that staying power so it lasts longer for you during your day.
Awesome. Thank you. Yes, and we love our primer. So we have a chemistry in action is our next segment, and we're going to move to how exactly scientists combine ingredients to create the products that we use. So over to you, Michelle. How do you turn a consumer need into a formula in the lab? And that would also be a good question for you, Nicole, because you are in the raw material space. But I'll start with Michelle, and then we'll ask you the same.
Yeah, so as a consumer, and I'm sure like all of us have been in this situation too, you're like, ooh, I really want a nice foamy shampoo that feels good when I'm like washing my hair, right? So that is part of the performance and part of the experience that you have when you're cleansing your hair. And so how how do we take that then? We say, okay, we need to deliver something that is going to allow for that really nice foamy lather in a formulation. And so we think about what that function is. So we need to be able to stabilize a foam for long enough. Again, there's a lot of surfactant technology where you have like oil and water interfaces that can be stabilized or bubbles that can be stabilized with surfactants in order to like deliver that very nice lathery foamy performance. So that's one example in like a shampoo. Similar things happen like frizz control that we talked about, right? So how do you reduce frizz? So we think about like what is the actual science that is going on there, and then how do we take that and develop a molecule that allows that to happen? So if I go back to the surfactant example, you typically have to have something that is loves water on one end and loves oil on the other end of that in order to get that right combination so that it delivers that performance.
And we're going to talk about testing in a little bit because, of course, that knowledge came with testing and trying and figuring those things out, right? So,
Absolutely.
yeah, so Nicole, so yeah, same question.
So yeah, I would say uh, what Michelle was saying too, but I could get into the testing a little bit too, but we so I know at L'Oreal we use like an outside panel that are trained like sensory expert. Like we use like a sensory panel, and they're like they're basically like calibrated in their senses, so that the chemists can make changes to the formula to achieve like a certain texture. And this trained panel of experts can essentially, detect if the formula is going in the right direction or not. And then once they achieve that certain texture or skin feel, then they can send it on to actual consumers for like a home use test. So they blind the product, and then the consumers use it in their homes, in their own routine, and they could use it for like 1 to 4 weeks. And then they ask, they answer questionnaires. Did you like it? Did it perform how you thought it would? And then, that's how we know if, we're meeting the need, a consumer need for a formula.
And that's how you decide if the formula is then ready for the consumers. Is that the same process?
Exactly, exactly. I mean, those are the consumer tests. There's safety tests as well, which I think we'll talk about in a little bit too.
Yep.
But those are the more consumer-facing tests that we do. We also do like package tests as well. We'll make sure that we test the formula in the package to make sure it dispenses the right way. We'll do package stress tests. We'll drop the package from different heights to make sure, if you're using I don't know, a bottle in your shower and you drop it like my kids do all the time, it's not going to explode and fall
Yeah.
over the place. So
You got to think
we
about
do,
everything.
we try.
I
We
love it. And
certainly
guess what?
try.
We appreciate it.
every time I hear a douche, and then I'm like, oh gosh, what did they drop?
I love it. And so back to the lab. Once a formula works in the lab, Stephanie, what challenges comes with making it at scale?
Yeah, so remember lab, like small scale, and we're trying to make it at large scale so we can get these products and ingredients into things that lots of people are using. So really our goal as process research engineers is to deliver the same material properties that give the performance consistently every batch or every run. And so sometimes the challenge comes in the complex chemistry that we're trying to control, where others, it's more of like a physical change that's happening and it's kind of the dominant factor. So an example is, right, a material that we're putting in a small mixer versus a large mixer would undergo different physical change, and that's going to impact kind of how it feels on your skin. So we try to find ways to predict conditions like this using math and modeling, so that we can get that same feeling and the same end result and performance across those different scales. On one of my favorite projects, we used to call it Feel Good Friday. And so on Fridays, we would go in the lab, look at a bunch of batches that we've made over several months, and put them on our skin and feel them and kind of record those sensory elements over time. And so that was a way for us to get data on, are we hitting the same conditions? Are there ways to tweak the formulation or the process to deliver the best sensory, and then make sure that it lasts and it's the same over time, so that our downstream users at L'Oreal, for example, can use it the same in their formulations each time.
I love that. And we have been talking for quite a while. We are almost at the end of this call, you guys. This has been so interesting. If y'all agree in the chat, just give us a thumbs up. So I'm going to jump to our lightning round and just leave everyone with some quick information. For these questions right now, one word or two words. Um, what's the biggest myth about beauty products that you'd like to debunk? Okay, three words, but we have 1 minute. You can go, you can
I
start,
would
Nicole. Yeah, sorry.
I would say that maybe that preservatives are bad. Maybe this is taboo,
Mm.
but um, if a formula has water in it, it has to be preserved.
Okay.
You don't want your formula to be growing molds and all of that. Preservatives are good. Sorry, I said it.
I like it. I like it. Okay. Stephanie or Michelle, you got one to three words for that one?
I'll just say they're not all the same, and everybody's skin and hair are different. So you can't just follow all the trends that your friends are using. You got to find what works for you.
Awesome. And so speaking of trends, Michelle, how do trends like clean beauty influence the science behind product development?
Yeah, so obviously clean beauty, like that is definitely a trend to go to like more natural ingredients, more biodegradable, environmentally friendly ingredients and that kind of thing. And so that is absolutely like aligned too with what Dow sustainability goals are and mission is. And so we look at that very closely here at Dow and look at how can we deliver really high-end performance while delivering it in maybe a natural, very natural carrier or a biodegradable carrier, or the base ingredient is biodegradable or from a natural source.
I love that. So now we are at our final questions. I'm almost sad to leave. This is a great conversation. Like I said, I'm learning so much. But we've talked about a lot, ladies. And if the students take away one thing from this conversation about chemistry and about the products they use every day, what, Nicole, would you want that message to be?
Um, I would say trust the science, especially from the big
Mhm.
companies. I think we see a lot of
Like it.
indie companies popping up, fast beauty, maybe you're buying stuff from TikTok Shop and they're fast and trendy for a reason and maybe they're not always the safest. They're going fast because uh, maybe they're not doing their due diligence. So I would say trust the science of the big companies.
And Stephanie, what advice would you give to your teenage self? Since I'm sure we got a few teenagers on the call.
Yeah, I would just want to remind you, and I still remind myself this every day. You are unique and you have so much to give. Things can be hard, but you can do hard things. So stick it out and find things that you love, and go do it.
I totally agree. And I'm just going to double click on Stephanie's advice, and that would be mine. Michelle, any
Yeah,
tips or advice?
I would say continue to find what you're passionate about
Mm.
and like jump into that with both feet because you will like work will not feel like work. Um, your like you will get tenfold back what you give when you are absolutely passionate about whatever that space is that you find that is your space.
I love it. And I saw a quote that I will say here. There is no traffic when you're in your own lane.
Mm.
Oh,
So
I love that.
I love that. So over to you, Jenny. This has been great.
That's amazing.
Oh, okay. Sounds good.
Thank Thank you all to our panelists. You got a lot of love in the chat, and people were commenting on how appreciative they were for how engaged you all were. So, thank you so much again, everyone, for joining us. This was the part one of the series, and part two is going to be on July 8th. So, we hope that you're able to
Hi,
join us
guys.
again and make sure that you connect with all of our panelists on LinkedIn because they're here for you. We're all here for you. So, we cannot wait to see you at the next one. Thank you so much. Happy birthday to someone. Bye.